Okay, so this is just another video looking at this concatenative synthesizer I've been working on. First thing I should say is that last time I noticed that the the audio levels were kind of all over the place. My voice tends to be quite low and mumbly, and then the audio that gets played back is very sort of loud and abrupt and full of pops and stuff like that. So it can be quite jarring, the difference between the levels. I've tried to adjust it a bit, but it's still far from perfect. So just bear that in mind when watching it, that there may be sudden shifts in volume. So just a recap of what this is, it's a command line synthesizer which is using the principles of concatenative synthesis, which takes a body of sound like a corpus of a pool of audio samples, and then uses that to construct an output audio file by weaving together different snippets of this audio. Sometimes that's done against a target, so you say try to find a way through this audio which most closely matches this target I'm aiming for, or you can do it in a free-form kind of way, which is what I'm doing here. So it will take each of these snippets and then just collage them together, but it won't just do it at random. It will look at features of the audio like the loudness and the pitch, and try to find samples that are quite closely matched to each other when it's selecting the next one to join together. And I'm trying to do these videos every time I make a major update to the software. It's still very much in its infancy, but what I do is I make myself a list of features. I'll show you on a different screen. I give myself a target, so I make a new version, and I have a bunch of to-dos that need to be completed before I move on to the next stage. And at the moment, I've just finished the 0.4.0, so I've added things like a testing framework and various other under the hood improvements. But what I wanted to show was that last time I showed that you could download a bunch of sounds from YouTube and create a sound that way. But another way you can also use it is by specifying a directory. So if you do this, look at the help. I can specify a directory and generate the sounds based on a folder that's already on my computer. So if I do, for example, I've got a directory here, I've got this jungle directory. If I wanted to make sounds just using sounds from that jungle sample pack, I could do this, and then if I just provide the input directory and I use, for example, breaks, so that's just going to use a bunch of drum breaks to make the sound this time. So if I use, I don't know, I can say how long I want each sample to be, so I'll say about 0.2 seconds, and how long I want the output to be. So if I just make it a output length, if I just make it a 20-second sound, we can see what that sounds like. Okay, output length. So there we go, it's loading 224 sounds into here. It's doing this analysis of them. And we should, once this is done, get an output. See, the analysis is much quicker now, because it used to do each one by one. But now what it's doing is parallelizing the task, so that it's doing multiple analyses on different threads at the same time. So we can listen to that now. That'll be in the output file. Play output. Let's put the I think I can say volume 0.7 maybe. So there we go. It's used those drum breaks to create a new sound, which has it's quite chaotic, as you can hear. But if I make it, I can make the sound even shorter. So if I make the slice length something like 0.05, see how that sounds. That'll give us much more. Okay, just got to to specify a crossfade time, 20 milliseconds. Forgetting the arguments to my own program here. Maybe X-fade. Okay. You know, normally in this case, the easiest thing to do is just to check the help again. Fade, just fade on its own, okay. So now let's try it. There we go, it's doing the analysis again, and now the sound is going to be just a couple of, it's going to be very short sounds for each sample, so let's listen to that now. So it's not even recognisable as a drum break anymore, which is quite interesting, I thought. Another thing I wanted to show is that I've made it much easier to add different types of feature extraction. At the moment I've got this registry of sounds, features, sorry, so it's detecting either the RMS, the pitch, or the spectral centroid, or all three. And the way it's doing that is using this Librosa library, which you can see here. I mean, that does a lot of other things beyond that, but one of the things it does is audio analysis, and they've got a list of different features you can extract here. So at the moment I'm doing this RMS, spectral centroid, and pitch somewhere else in here. You know, it's just a one-line thing for each one to say, you know, Librosa feature extract the RMS, and I just wanted to show you how easy it is to add another type of analysis to this. So if I go into here, into this feature registry, and I want to add another one. Let's call it, let's have a look what we can do. Since we're looking at the drum breaks, we could use something like the tempo. So looking at the tempo, if we want to add that, it should be as simple as saying, okay, it needs this Y, samples, sample. Okay, let's just try that. If I say tempo, and then tempo, let's make another entry here. I'm doing this in the reverse order, by the way, before anything. So it's a new feature. Name is tempo, and extractor is going to be extract tempo. So I make a new function which is def extract tempo. It's got the same arguments and return type as the other ones, and it'll just be return. Just got to check what it returns, because the other ones would return things frame by frame, but I think here the tempo is just an overall value for the whole sound. So depending on, if you've got one, it'll give you an array, but if you've just got one channel, there's only one entry in it. Okay, so what I do then is just say that Librosa feature tempo Y equals samples and SR equals SR. And as I said, that's returning an array. So if I've got stereo, there'll be two values in there, and what I'll do is just that, just to get the first thing out of there. So that's all I have to do to create a new feature to analyze. So if I now look at the help again, you should see that the features here, it already has tempo as an extra feature that it will extract. So I can redo the same analysis as I did before, and it will also use tempo information now to get the audio. So what I'm going to do is provide an extra parameter which is features, and then if I type in tempo, it will only use the tempo as an extractor now, and as you can see, the analysis was really quick this time. So now what it should do is just base the construction of the audio just on sounds with quite similar tempo values. So if we just listen to that again one more time, what came out. Well, you can see that it's once again still quite chaotic. And to help with this kind of thing, I've made another way to plot features based on across the whole pool of sounds. So if I run this, you'll see what I mean. It's creating a histogram of the sound. Okay, so that's not very useful, is it? At the moment, it's actually using a max clip length of 0.2 seconds, which I don't think is long enough for it to detect the BPM of the audio. So if I run it again, yeah, okay, that's much more reliable. So what we can see now is that across these 224 drum samples, this is the distribution of BPM. So around here, probably about, I don't know, 165 to 168 or something like that. We have about 40 of the sounds fall into that BPM range, and just slightly over 40 fall into this BPM range here as well. The fastest ones we had were at about 230 BPM. So this is a good way to visualize across the whole corpus of, or the pool of sounds you have, what range of BPMs you have, and yeah, there we go. So yeah, that's just an overview of another way of using this software that is different from what I showed last time, where it downloads random clips from the internet.